Welcome back to Class 10 Science, Chapter 3, Metals and Nonmetals. This is the part 2 video of this chapter. In the first part, we had covered the physical properties of metals and nonmetals. In this video, we will cover the chemical properties of metals and nonmetals. In the part 3 video, we will cover the ionic compounds. And in the part 4 video, we will cover occurrence and extraction of metals and corrosion. So now let us understand the chemical properties of metals. So in this we will cover 4 properties. First, reaction of metals with oxygen. Second, reaction of metals with water. Third, reaction of metals with acids. And fourth, reaction of metals with other metal salts. First, let us see the reaction of metals with oxygen. So when metals are burnt in air, they combine with oxygen to form metal oxides. So metal plus oxygen gives metal oxide. For example, when the magnesium ribbon burns in air, it forms magnesium oxide and gives a dazzling white flame, as you can see in this animation. Many metal oxides are insoluble in water, but few metal oxides dissolve in water to form alkalis. So most metal oxides are basic in nature. For example, when magnesium oxide is dissolved in water, it forms a strong basic solution of magnesium hydroxide, which turns red litmus to blue. So this confirms that magnesium hydroxide is basic in nature. Some metal oxides show both acidic as well as basic behavior. Such metal oxides are known as amphoteric oxides. For example, aluminium oxide. So aluminium reacts with oxygen to form aluminium oxide, which is Al2O3. Now this aluminium oxide can react with an acid such as hydrochloric acid to form aluminium chloride, which is a salt, and it can also react with NaOH, which is a base, to give sodium aluminate, which is a salt. So now let us see, do all metals react with oxygen at the same rate? So different metals have different reactivity rate and they react with oxygen in different ways. Let's see this. So metals such as sodium and potassium, they react very vigorously with oxygen, and they can even catch fire if left in open. And this is the reason they are kept immersed in kerosene so as to prevent the accidental fires. Metals such as magnesium, aluminium, zinc, lead, they react to form a layer of oxide which gives them a dull appearance. Third, iron. So this doesn't burn even on heating, but if we take very small pieces of iron, which are known as iron fillings, then iron fillings burn vigorously when sprinkled in the flame of a burner. Fourth, copper. So this doesn't burn on heating, but on prolonged heating, it reacts with oxygen to form a black colored layer of copper oxide. And metals such as silver and gold, they don't react with oxygen even at very high temperature. So on this basis, we can say that sodium and potassium are the most reactive metals, then magnesium, aluminium, zinc, lead, then iron, then copper, and then silver and gold. Now let us see how the metals react with water. So metals react with water to produce a metal oxide and hydrogen gas. So metal plus water results in metal oxide plus hydrogen gas. Now this metal oxide reacts with water to form metal hydroxide. Now let us see the reaction of different metals with water. So metals such as sodium and potassium, they react very vigorously with water, with cold water only. And then this reaction is so violent that the evolved hydrogen gas catches fire. So this reaction can be stated as potassium plus water results in potassium hydroxide plus hydrogen gas plus heat energy. And similarly, sodium plus water gives sodium hydroxide plus hydrogen gas plus heat energy. Second, calcium. So this reacts with cold water but less violently. So this means that calcium is less reactive than sodium and potassium. And this doesn't catch fire. So this reaction can be stated as calcium plus water gives calcium hydroxide plus hydrogen gas. So third, magnesium. So this doesn't react with cold water but it reacts with hot water. So this means that it is even less reactive than calcium. And magnesium plus water, hot water, gives magnesium hydroxide plus hydrogen gas. And this magnesium starts floating because bubbles of hydrogen gas stick to the surface of this metal. So this is a unique property of this magnesium metal when it combines with water. Fourth, metals such as aluminium, iron, zinc, they don't react with hot or cold water, but they react with steam. So aluminium plus water gives, in the form of steam, gives aluminium oxide plus hydrogen gas, and iron plus water in the form of steam gives iron oxide plus hydrogen gas. Fifth, elements such as lead, copper, silver and gold, they don't react with water at all. So they are least reactive. Third, reaction of metals with acids. So metals react with acids to give a salt and hydrogen gas. So metal plus dilute acid gives salt plus hydrogen gas. So now let us check, do all metals react with the acids in the same manner? So for this we will check the reactions with two acids, that are hydrochloric acid and nitric acid. First let us check the reactions with HCl. So sodium and potassium, they react very vigorously. Magnesium reacts quite rapidly, forming magnesium chloride and hydrogen gas. And then we react other metals such as aluminium, zinc and iron, and we find that sodium is the most reactive, then magnesium, then aluminium, then zinc, and then iron is the least reactive among all these metals. But copper, it did not react with dilute HCl, so it is the least reactive. Now let us check the reaction with nitric acid or HNO3. So hydrogen gas is not evolved when HNO3 reacts with metals such as Zn, Fe, Cu, Al, etc. And this is because HNO3 is a very strong oxidizing agent, and it oxidizes the H2 which is evolved into H2O, and itself it gets reduced to oxides of nitrogen. But some metals such as Mg and Mn, which is manganese, they react with HNO3 to form hydrogen gas. So now let us discuss about a very special acid which is aqua regia or royal water. So this is a freshly prepared mixture of concentrated hydrochloric acid and concentrated nitric acid in the ratio of 3:1. So we take 3 parts of HCl and 1 part of HNO3 to form aqua regia. And this is a very special acid as it can dissolve metals such as gold and platinum, which the other acids cannot. Fourth property of metals is that reaction of metals with other metal salts. So the more reactive metals can displace less reactive metals from their compounds in the solution or molten form. So metal A plus salt solution of B results in a salt solution of A plus metal B, and it is given that metal A is more reactive than metal B, and only a more reactive element metal can displace a less reactive metal. I have discussed more about displacement reactions in my video on acids, bases and salts part 2, and I have provided the link in description box so you can watch it. So now let us discuss the metal reactivity series. So after performing displacement experiments on all the metals, the reactivity or activity series of metals was developed. And in this reactivity series, the metals are in decreasing order of their reactivity. So this means that the most reactive metal will be on the top of the series, and the least reactive metal will be on the bottom of the series. So the series is potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver and gold. I have provided a trick to memorize this entire metal reactivity series in a video, and I have shared the link in the description box so you can watch it. So now let us discuss the chemical properties of nonmetals. First, reaction of nonmetals with oxygen. So nonmetals react with oxygen to form acidic oxides. Second, nonmetals don't react with water or steam. Third, nonmetals don't react with dilute acids. And fourth, reaction of nonmetals with salt solutions. So a more reactive nonmetal displaces a less reactive nonmetal from its salt solution. So this is all for today. In the third video, we shall discuss ionic compounds and their properties. So stay tuned.